Okay, so I need to find slope of each of these lines for line 1 and let me get a different color. For line 1 and 2, both of those, it looks like I'm going up 1 and over 2. So my slope would be 1/2 and 1/2. What kind of lines are lines 1 and line 2?
Parallel.
They are parallel, right? Show me 2 parallel lines with your arms. Okay, most of you by default go like this. Okay, which is fine. What do you know about parallel lines?
They don't touch. They will never touch no matter how far you go, right?
Okay, I'm hearing a lot of different versions of basically they never touch, right? So I want you to keep your parallel lines up really quick. Okay, and I want you to make them still parallel, but I want you to like slant them to the side. Okay, so no matter how much you're slanting to the side, you notice they are still going at the same angle, right? At the same rate, so that they never touch.
Yep.
So what do you know about the slopes of parallel lines? They have to be the same, right? If we look at lines 3 and 4, lines 3 and 4 are parallel to each other. And each one of those, it looks like it's down 2 over 3. So my m would be negative 2/3 for both of these lines, right? So my conjecture on number 2, parallel lines have the what? Same slope. So anytime you read the word parallel, what should you think? Same slope. Every time you read the word parallel, you should think same slope every single time. Okay? All right. Let's take this a step further. And now I want you to take that knowledge that parallel lines have the same slope, and I want you to apply that knowledge by doing problems 3 and 4 together with your partners. This is going to stretch you a little bit. It's going to be a little difficult. You're going to have to work hard. Okay? I want you to take the knowledge that we just talked about on numbers 1 and 2, and I want you to apply it to numbers 3 and 4. Okay? Go ahead.
Oh, I think I figured it out.
So number 3 says, determine the slope. So remember, all I care about here is slope of a line that is parallel. What do you think of when you read the word parallel? Same slope. To the line whose equation is y equals negative 3x plus 4. What is the one and only one thing that I care about with that line that they give me, the y equals negative 3x plus 4? I care about the slope. So what is the slope of that equation? Negative 3, right? I always know if it's in slope-intercept form, which is y equals, that the slope is right next to x. So the slope is negative 3. What did you think of when you read parallel? Same slope. So what is the slope of a line that would be parallel to that? Negative 3. M equals negative 3. Okay, let's take it a step further. So now it says write the equation of a line parallel. What do you think? Same slope. So something with the same slope as this line. And has a y-intercept, so a b of 0, 5. So it tells you the b is 5. And what, again, do you think when you read parallel?
Same slope.
Same slope. I know you guys are like, oh my gosh, Mr. Craw, we get it. But I want to say it about 5 million times so you don't forget. Okay? Parallel is same slope. So, what is the slope of the line they give me? 3/4. So the slope of the line that I am writing is 3/4 because it's parallel. And now we're back to same old, same old. Asking yourself what information they give you and what option of formula on the board is going to be best for you. So what information do you have now? You have the slope and the b, 5, right? You could take it as a 0.05, but you'd be doing a little too much work because they give me specifically the y-intercept is 5 here. So if I have an m and a b, which form am I going to use? Slope-intercept, straight into it. Y equals m, which is 3/4, x plus b, which is 5.
They make that seem like
Really hard.
so hard.
Yeah.
If it was worded differently, I could have done it.
I mean, I don't know how it would be worded differently.
I know, I just.
It's not.
Why couldn't they just say b equals 5? Instead of putting it 0.
Because they require you to use your brain.
That's not fair.
And read y-intercept of 0, 5 is the same as b equals 5. Okay?
No, but they want
All right. So that is parallel. Actually, we have one more problem to work. Okay, flip over to the next page. And I want you to do 8 together with your partners. So on the next page, do 8 together with your partners. Go ahead. Okay, so looking here, it said a line parallel. What do you think? Same slope.
Same flow.
So line parallel to that line and passes through the point 1, 4. Okay, so first it asks you what's the slope of the line that we're going to use. If it's parallel to that equation, what slope are we going to use? 3, right? Because it's the same slope as the one that they give. So the slope of the line that they give is 3. So the slope I am going to use is 3. That's parallel. Then I want to write an equation. Well, I need more than just slope. What other piece of information do they give me? In this case, it's a point, right? Not the y-intercept. So if you have the slope and you have this point of 1, 4, what form do you think you should use now? Point slope. So this is going back to the old stuff, right? After we figure out slope, it's just what we've always done. Okay? So now I have a point and a slope, so I'm going to use point slope form. Y minus y1, which is 4, equals an m of 3, parenthesis x minus x1 of 1. And then, so that's point slope. Remember, all my final answers should be in slope-intercept, so I need to distribute. So y minus 4 equals 3x minus 3. Add 4 to the other side, and you end up with a final answer of y equals 3x plus 1. Okay, so not too bad. That's parallel. Now let's look at perpendicular. Okay, so to speed up the process a little bit, we're going to do number 9 and 10, but I want you to take out line 6.
Line 6.
L6, line 6, yep. Okay, so I want you to do line 5 and line 7 because those are the two that are perpendicular, and I want us to focus on those. So graph them, think about their slopes, and then go through and try to write a conjecture or a guess about the slopes of perpendicular lines, okay? All right, go ahead. Okay, so you can see my two lines graphed. What do you know about perpendicular lines? Actually, show me perpendicular lines with your arms. Okay, I see mostly perpendicular lines. I don't want you to confuse perpendicular and intersecting. Any two lines that touch are intersecting. What makes two lines specifically perpendicular?
90 degree.
Okay, they cross at a 90-degree angle, right? So they cross at a 90-degree angle. So these two lines cross at a 90-degree angle. We need to know then what does that mean about the slopes of perpendicular lines. You see the slopes are -4/3 and 3/4. I want you to take a quick 30 seconds and I want you to talk with your groups about what is the difference between those two slopes. Go ahead.
The numerator is negative on line 5. The numerator on line 7 is positive.
And
That too. That too.
Okay, so what are some things you found? Who can tell me one thing about the differences between those two? Yep.
Negative.
What?
One's negative.
One's negative, one's positive. What do we call numbers that are positive and negative? Like 5 and negative 5, or 10 and negative 10.
Integers.
They are integers, but specifically like 5 and negative 5.
Absolute value. Okay.
Opposites, right? 1 and negative 1, 5 and negative 5. You making it way too hard. Okay, so they are opposites. So I'll start off here. That's not it, but that's part of it. So the slopes of perpendicular lines are opposite, but they are something else. What else? They are opposites. One's positive and one's negative. What else is different about them? They're flipped. What mathematically, what do we call that when fractions are flipped? It's right on the tip of everybody's tongue. Starts with an R. Reciprocals.
Rational numbers.
Wow, that was a lot of different R words. Reciprocals.
Reciprocals.
Okay, so they're opposite reciprocals. Okay, so opposite reciprocals. So when you read parallel, you should think same slope. But when you read perpendicular, you should be thinking opposite reciprocal. Change the sign, flip the fraction. Okay? All right, so now let's take this concept of perpendicular, and now let's apply it to a problem. So go ahead and scroll to the next page. I'm going to give you a tough task. I've already had a conversation with some of you today about easy problems and hard problems, and I realize this is going to be a hard problem. Okay? But I would like you, together with your partners, to do number 23. It is the toughest problem you'll do all day. Okay? I'm being serious. Okay? So put your minds together, turn your brains on high, okay, and let's work through this problem together. Okay? I'm going to give you some time here to work on number 23 together with your partners. Go ahead. Okay, so toughest problem today, and that's okay. So it's all about, remember I always talk about this, the process of algebra, and really the process of any problem in life is, what's my end goal, where do I need to go, what am I given, and how do I get there, right? So my end goal is to write an equation that is perpendicular to this. If it's perpendicular to this 2x plus 5y equals negative 15, what do I need to know about that line 2x plus 5y equals negative 15? I need to know the slope. That's the one and only thing I need to know. Do you know the slope right off the bat on this problem? No, because I need slope-intercept form, right? Try to coach you up a little bit on that one. So I need to solve for y. That's the first step in this long process. So I have 5y equals negative 15 minus 2x. Keep going. So I have y equals negative 3 minus 2/5 x. So now, do you know what the slope of this line is?
That's what this line is.
This line is what?
Negative 2 over 5.
Negative 2 over 5. Okay, so there's goal 1. I know what the slope of this line is. I need to go back, again, to my problem and reread. So it says, write an equation of a line that is perpendicular. When you read perpendicular, what do you think?
Opposite reciprocal.
Yes, kind of. Opposite reciprocal. Okay, opposite reciprocal. So if the slope of that line was negative 2/5, what is the slope that I am going to use?
5 over 2.
Opposite would be positive. Reciprocal would be 5 over 2. So now I have a slope. Do I have anything else to work with? Because I need to write an equation. That's the end goal. I am given a point, right? So if I'm given this point, negative 8, 3, now I have pretty much everything I need, negative 8, 3. So now I have everything I need to write an equation. And this goes back to what we've done prior to this, right? You have a point and you have a slope. So what should you do?
Point slope form.
Point slope. There you go. Okay, so we have y minus, y1 is 3, equals the m of 5 halves, parenthesis x minus a negative 8, which changes to plus a positive. Distribute, so y minus 3 equals 5 halves x plus 20. Add 3 to both sides. And there's my final answer. Y equals 5 halves x plus 23.
That's the number of the problem.
Okay. So let's just zoom out and take in all that we've done. Look at all that beautiful math work right there. Okay.
Beautiful.
All right. Oh yeah, it's beautiful. Okay, we have one more problem that I want to go over with you really quick, and it does not require a stylus or finger on your iPad or anything. So go ahead and put it down. Take your finger off the iPad and look at the screen. Okay. So it says 24 says determine the equation of a line that is perpendicular to the x-axis that passes through that point. So let's work through this logically. So give me the x-axis. Let's use that as our starting point. So show me the x-axis with your arm. Everybody's got to do this. Come on. X-axis. Everybody. X-axis. Okay. Now give me perpendicular to that. Just one arm. Just one arm. One arm should be held up that is perpendicular to the x-axis. So this is my x-axis. Here's perpendicular to the x-axis. So, ta-da, we know this is a special case, right? What kind of line is this? Is it a vertical line? Is it an x equals or a y equals? X equals. It's always opposite the axis, right? So this might be the y-axis, but it's an x equals line. So based off of your point that they give you, what should x equal? On number 24. 4. So my answer is x equals 4. Okay? So you can see how some of these problems take a whole lot of work, and some of these problems take a whole lot of brain power. Okay? That one was all in your brain. Okay? All right.